And looks like we're live. Looks like welcome. Welcome back. Yo, what's up? Today we're working on re-implementing the Windows 95 maze screensaver in Godot. So I am a programmer. Programming is boring to watch, but for some reason people still do it. But I think that I want to give something kind of more entertaining to look at than just me and some text. I think that this is pretty fitting to do the Windows 95 maze screensaver. This guy. If there's anything that I've spent hours and hours and hours and hours of looking at, it's this. So what I want to do is I want to re-implement this in Godot, the game engine. My thoughts there are it would be fun to extend this into something else, kind of throw in some characters, some coins. Maybe there's also we could merge this with Temple Run to give that extra satisfaction. Yeah. So this is probably something that you could implement just in raw OpenGL. Of course you could, because it was implemented in 1995 in Windows pretty easily. Yeah, so let's give that a go. I have opened this Godot project we were working with last stream. I think there's nothing in here that I really want to keep, so I'm just going to delete everything. Maybe not the export presets. And just delete everything here. Start from scratch. So the first thing that we're going to want to do is procedurally generate a maze, probably. And so there's two stages there. One is actually generating the maze. And I think there's this thing like procedural maze generation. Here we go. And quick Wikipedia read gives a pretty straightforward implementation. So if you just take a grid of points, let's we'll just draw some horizontal lines. We can start at a point, any of them, it doesn't really matter. Let's say we start here. We then look around and we say which way do we want to go? We just pick one randomly, so we go here. And since we went there, we know that that path is now able to be gone through, so we need to erase the wall. So you go this way, like this. And then here, we do the same thing. We go here, and we just keep moving randomly, until we hit a dead end. So if I went like this, I'm oh, there's nowhere else to go. Everywhere else has been seen. Then I walk back, and I go, oh, what about over here? And I take another path like this, and I go, oh, dead end, come back. And then here I go like this, dead end, go back like this, go back, 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 back. Oh, here's an path here. And now we have a maze. This is a pretty poor maze, but the algorithm is fine. And with enough points on your grid, then you've got something kind of workable. What we don't have here, though, is a way to map that into a world in Godot. And so I think I'm pretty confident that this will be easy to implement. And the thing that I'm less sure of is how to procedurally generate the terrain, I'll call it. Terrain is a pretty strong term for what we're doing here. I just want to see what happens, how I would procedurally generate the world, I guess I'll say. And so I think that there's something in Godot I was reading, and I found something called a grid map. I think this is the one. Node for 3D tile-based maps. Yeah. So we can think of the maze as Minecraft, right? And we can say each of these is a block, and we'll just stitch a bunch of blocks together to make our final grid. So here's where I get lost. I have absolutely no idea how to use this. So we're gonna do some Googling. Godot grid map. And as always, they have some pretty sick docs. Let's take a quick look. Obviously, you could like procedurally generate just like walls and stuff, but I think that this is easier. We can just make 4 tiles. 4, I think, because you have in each point we can either have a 3-way intersection, a 4-way intersection, a straight line, or a 90-degree turn. And I think that's all the options, because I guess, or a dead end. You could have a dead end. I think that's it, because this guy can be rotated anyway. This guy can be rotated 90 degrees to make the sideways one. This covers all possibilities with 3 openings. I think 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, that covers everything, and this is symmetrical. Yeah, so I think we can make like a tile set of 5 tiles, and then just instantiate that on our grid. So how do we use these? We can just open this grid map starter, or maybe we can just skim this docs. Mesh library looks like we just instantiate each of our meshes in the mesh library. Then we export the mesh library and use the library that we exported as the grid map, maybe? Let's see. Okay, let's try that. So we're gonna start by just not doing... Ooh, thunder. That's kind of fun. Wow, it's really loud. Oh my gosh. It's still going. That was a good one. Boom, 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 boom. Wow. Well, we keep going, but that's sick. Wow, it's still going. Thunder's cool. Oh my gosh, it's still going. Vancouver weather thunder. Is it? Epic thunderstorm videos. Look at that.
Booming thunder day. Australia.
Oh, that's not a picture.
Hashtag BC storm.
Vancouver'sAwesome.com. What am I doing? This is from 20 hours ago. Vancouver weather. Do we see any? Whatever. Wow. That was sick. That was so long. That was the longest thunder I've like ever heard in my life. That was like 20 seconds. Okay, anyways. We go back. What were we doing? We were looking at how would we make a grid map. Okay. So it looks like the grid map has to import a mesh library. Yeah, so here they somehow got this in here. Filter meshes. Use a mesh library resource to give this grid map. Okay, so we'll add a mesh library. That's not there. So we need to first create something. Grid map mesh library scene. Okay. Like all mesh instances, it can be assigned. Oh, I don't need can. Although navigation meshes sound interesting. That's gonna be maybe useful. Maybe not. We'll come back to that. Blah blah blah. Oh, I don't want to like. I guess I can just open this. Fine. For an example. Fine. Let's extract this somewhere. Just into downloads is fine. And we can open this with Godot. Oh, but Godot isn't like installed. Can I just open project? I guess I'll just make a new Godot instance. Let's go into the download folder and open it. We have to open the shell, or open a shell that has Godot in it, because I don't have it installed for real. Open a project. Okay. That's useless. Why didn't this work? Oh, because I haven't opened anything, maybe? Here we go. Here we go. So we make like a scene, and each of these guys has... He's like a mesh instance 3D. Okay. I think. And then how does he export? Oh, maybe this is from this? Grid map demo? No. What's this? This is the resource as it was generated, so this must be how we generate one. Okay. So we just drop them all around. And these do have, like, their positions are set, and I guess that doesn't matter, probably. Okay, we're just gonna try generating generating one that has like one item in it, and then we'll come back to it. So let's add a cube. I think it's called box. Sure. We'll just call this our tile for now, and then see how if we can export something sane from here. Blah, blah, blah. I don't really care. I don't care. Exporting the mesh library. Scene, export as mesh library. Okay. So we'll call this the mesh library. And we will export this scene, export as mesh library. And we'll call this mesh library again. So now we have a grid map, and we can assign the library, probably. Where does this come from? Oh my gosh. What do they say here? Using grid map, blah, blah, blah. And dropping into the theme property. Where's the theme property? Theme. It's nowhere. Nowhere. Oh, here under grid map, I have to... Okay. What does new mesh library there do? Do I have to actually, like... Oh gosh, go back. It also doesn't seem to have any of the meshes, so I probably have to mark this as something that I want to export. Probably. Blah, blah, blah. Sure, and it has a number of mesh instance 3D. Oh, so this isn't a mesh instance 3D. Oops. So let's do this, and then this guy can go in here. We'll try exporting this again. Okay. Oops. Okay. Is there any meshes in here? Hello? Blah, blah, blah. Collisions, I don't care about this. I don't care about this. So I'm missing something. Because in this project, these are all yellow. Why are they yellow? Because they're arrays? Like... Oh, what am I missing? Maybe I should just actually read. Collisions navigation can also, but we don't have to. Create a mesh library, which is a collection of individual meshes that can be used in a grid map. Okay. The scene has a node 3D root. Yep, got that. And a number of mesh instance 3D nodes as children. Sure. If you don't need physics in your scene, then you're done. Okay. Then we export. So, like, what am I missing? He literally, like, that's what he says. That's all I need. That's all I need. Help me. Help me. Help me. Scene, export as mesh library. Okay. And then it's like, womp womp. Why? Why? I must be missing something. I must be missing something. Let's just do the classic close and reopen, because I don't know what I'm doing. Okay. And I think I have seen that resources don't refresh well. Grid map. Okay. No, I don't get it. I don't get it. Hmm. Uh-oh. Uh-oh. I don't... Oh, wait, what's this? 0, 1. Maybe the, like, box that I added to my... Maybe, like, this isn't right. So let's delete this. Ah, here we go. Aha. So the mesh itself has to be like in here. How do I like edit a mesh instance 3D? Mesh instance 3D. Takes a mesh. Blah blah blah. How do I like create one? Oh, here. Perfect. New box mesh. Here we go. This is probably what I was missing. So now if I export this as a mesh library, can I then look here and look at this. Perfect. Okay, so now how do I edit the grid map? What is this? Number 2, number 1. What did I just do? I don't know. Can I just like drag this in? No. Okay. What does it say I should do? Using grid maps. The cell size property should be set to the size of your meshes. You can leave the default demo, blah, blah, blah. Choosing a tile from the palette and clicking it with left click in the editor window. I would like to click this, please. I would like to... Oh. What the heck just happened? Okay. Well, that's good. Okay. And so these just need the grid needs to be edited to say 0.5. Wait, 1. Where's the like size? Oh, here. 1, 1, 1. Oops. Wait, what just happened? Where'd I go? 1. Oh, here we go. Okay. And so now I can go in here, and this is just bugged. I don't understand. Like, oh, because I don't know how I ended up with these in here. I like went in here and started like editing stuff. Whatever. Okay, so that's easy. So this is my building block. Okay. And now I want this to be like a hallway. And since we're only going to ever be inside, we can get away with only having one face on the inside. The outside can be see-through. So let's make our mesh library. I assume that it would make more sense to make the library in Blender. I'm assuming that like the editing capabilities for the meshes here aren't great. So let's just kind of take our box and we will make a hallway out of this. So let's just kind of do like, let's open up the reference from Windows 95 Maze. So it looks like, here we go. kind of short relative to wide, I think. I don't think it's square. So let's do something like this. The walls are infinitely thin, which is good for us. So we can actually just get in here and we'll just make our different versions. So we'll make, oopsies. Okay, so first we need to flip all the normals so that they're facing inwards. Let's just quick face orientation. Good, everything's inside. So our first hallway is the dead end. Call this dead end. And I guess, do we save this into our stream simulator thing? I guess so. Meshes. Okay. And now we... Oh, oops. I accidentally undid something. Dead end. Okay. So now we duplicate this. And we call this straight through. We don't want the light. We don't want the camera. And the straight through version has this gone. We will call this 90 degree. And we will put this face back. So we need to go and stitch this together. Boom, 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 boom. And delete this face. This is a 90 degree turn. What am I missing? I'm missing the three-way. Call this three-way. There we go. And is that all of them? What did I draw in paint? 90, straight, three-way. Oh, four-way, which is just nothing. Four-way is just floor and ceiling. Oh, oops, okay. We'll duplicate this and call this one four-way. And in the future, we will actually texture these, but for now I don't really care. This is like good enough to get going. Okay, so I will save this, and I will think I can just export the whole scene as a GLTF, if I remember correctly. Export GLTF. Calls meshes glb. Okay. And so probably now in Godot I can look at these, and I can probably actually re-import this as a... I wonder if I can like add this to my node instance 3D here. Delete nodes, so here, and I just go add child node, mesh it. Nope. Add meshes. No. Where's the like... Do I just drag it? Okay. Sure. And now if I export as mesh library, what do I see in my scene editor? Dead end. I only see one. Can I... Like, what do I see here? Yeah, so here if I instantiate this, I do see four meshes, but these don't get imported into the mesh library correctly. Can I just use this directly as my mesh library? That'd be cool. Quick load. Load. No. Can I export? Here, can I just Godot GLB as mesh library? Okay, so somebody proposed it, but it looks like it doesn't exist. Which means that I do, in fact, need to instantiate this. So let's make our mesh library scene, and can I like... I guess I want like new inherited scene. And I save this as my mesh library. Okay. Fuck, I can't overwrite something that's still open. Well, stop protecting me. Okay. And now I can just export this as a mesh library. And hopefully this does what I want. Ah, here we go. Yeah, I have them all here. Nice. So how do I like clear what I have here in my grid map already? Like right click? Yeah, here we go. Hey, yeah, haha, yeah. Okay. How do I delete everything? How do I delete, remove? Now you can start by left click on the editor, use right click to remove tile. So why can't I remove all these tiles? Because I'm under? I am under. Yeah. Perfect. Get out of here. So now I could. Okay, my objects are bigger now. So it's 2 by 2 by 2 now, I think. Is that right? And yeah. Is there a hole? What the hell is that? Oh, that's just light. That is just light. Can I rotate this? R? No. Click. How do I rotate? Pressing S. Okay. So let's make a... Yeah, nice. So let's just kind of see how this looks. Do I want to make this a dead end? Yeah, sure. I'll just make 2 dead ends in there. And then let's go inside and take a look. Oh my gosh, it's so hard to... Yeah. Okay, so those piece together nicely into like a box. So we're chilling. We are chilling. So let's rename this. No, can we rename this scene? Scene. Can I like rename to like maze.scene? Cool. And presumably we're also going to need a camera. But I guess here we actually want to procedurally generate the scene. Okay, let's just get... What's the best way to visualize this? Is backface culling on? It'd be nice to just be able to see through the top. Like if I go like... If I go like this, I want to see the lines from on top. How do I turn on backface culling? Backface. Godot. Backface culling. Because since these aren't like real 3D objects, right? These are just like one... how do I say this? Everything has like a thickness, and these are 0 thickness, which means that like these red faces are actually like inside of mesh that you're not supposed to see, right? If I wanted this to be like a real object that has like that you're supposed to view from both sides, I could go in here and I could like solidify it. I think. Can I not? What the heck? What am I doing wrong? Add modifier, solidify. Here we go, yeah. So here I could give it a thickness, then you see when you look from this side, there is like a little bit of thickness to it. But since I haven't done that, this is just like an infinitesimally thin plane, and these faces are never supposed to face the camera. And so what I want to do is ask Godot to just not show me those faces. And that's like a thing that OpenGL usually does, right? It like says, oh, if I'm seeing the back face, just don't draw it, because like why would you draw the back side of something that you know you're never gonna see? So, spatial parameters, call mode should be set to the back. Okay, check my material settings. So maybe there's just no material on these things. And maybe I need to fix that. So how do I look at the material? Mesh. Surface, material. Here we go. Backlighting. What did this guy say? Spatial material parameters call mode. So material call mode. Here we go. Oh, I can't edit this. Why not? Why not? GL. I guess because these are like imported objects. Can I not edit this material on here? Yeah, it does look like this is just in the GLB. Okay, so GLB call mode, Blender. Can I set that? Blender sets based on EV material. Okay, so in Blender, I actually have to go in here and edit the material. How do I... Back call. Oh, here we go. And are these guys all using the same material? Nice. Nice. So I can just re-export this again. Overwrite it. And then does Godot automatically? Yeah. Yes. Look at that. So now if I go, hello, why can't I click? Oh. It crashed. Very cool. We'll just pretend it didn't. But yeah, that's really nice. So now I think if I go look at my original scene, which is this, why these should be called now. So I might need to, I need to re-export the library. Oh, that's so annoying. But that's looking pretty good. So now we can visualize it by just looking from above. There's a problem here, I think. Oh, probably because these are 3 ways and they're supposed to be 2. Oh, that's interesting. So these are they only show a wall on this side. That's kind of interesting, but we'll ignore that for now. So let's do this. So we'll start with a straight hallway. Nice. And another straight hallway on the other side. Okay, that's kind of nifty. And then we'll do a 90-degree turn here and here. Okay. Yeah, that works for me. And now when I look from above, I see like something of interest. Sweet. So now we have our tiles. We have something that we can look at. Let's add a script now to do like the procedural generation. So I think we need to rename this to no, this is fine actually. We have no renaming here. This is the maze. And we will not instantiate like a camera or anything here. That'll be in like a parent scene later. And so in our, let's just do it at the top level. At the top level, we make a script, and we'll call this maze.gd. That's fine. And on ready, we need to basically procedurally run the procedural generation. All right. So I guess we just start running the algorithm. So there are going to be parameters here. GD script. I don't know any GD script, so let's look up GD script constants. Or is there like, can I download Godot docs here? Nope. Okay, so I can just make consts. Okay. So const maze size, we'll make it a square for now because, or we'll call it size. And what was this? What was the syntax here? What's the colon equals? Whatever, doesn't matter. So we'll make this like a 16 by 16 at first. When we are ready, we will start editing the grid map. So we'll just call this grid map. And is there like a clear? Okay, well, first let's set up our scene. So we need to create a new scene and we'll call this game. Or yeah, whatever. And in here we will add a maze, which we need to rename. Should be maze. So this should be maze in our game. Hello? Where is the map in here? Oh, it's just over here. So can we just slide all of this over? Grid map, copy paste, godot is what I'm looking for. Womp, 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 womp. Using grid maps. Copy. No, move. Can I really not just like move everything over? Holding shift and dragging with left mouse will draw a selection box. Here we go. And then can I like move it? Oh no. Right click. What does the selection box do? Menu options. Menu options. Where are the menu options? Hello? Shift? Am I losing my mind? Oh my gosh. What does this mean? What does it mean? Where's the menu? What the hell? Lock? No. Group. You can duplicate. Where could I possibly duplicate these? Right click. No, obviously not. Obviously not. Ah! No, because those are properties. Project, scene. Oh my gosh. I'm gonna lose it. I'm gonna lose it. Ah! Like, there's meshes? That's not what I want. Transform, view, transform, view, transform, view, gizmos. Transform. These are not for this, right? Why? Come on, man. Duplicate grid map godot. Do I have to like look up a YouTube video on how to like do I actually Control D, someone says here? However, there's a copy icon on the right in the menu bar. No, there's not. Don't lie to me. Okay. What if I Control D? No, Shift D, Control D, Control C, Control V. Or press M, then drag. This must not be for the right thing. No, this isn't. Oh, what's this? Duplicate selection. Oh my gosh, okay. That was hard. That's a menu? Look at that. Does that look like a menu to you? Not to me, but that's okay. It's fine. It is fine. We did it. We figured it out. Ooh, I was getting heated. I was getting heated. All right. All right. So now I have this, and I hit play. I need to set up a camera here too. So camera. And I think I need to set this as a root node somehow. Set as main seed. Here we go. So now if I get my camera, I can move it up a little bit. And move it to the side. And now when I hit press play, I should see myself like in a hallway. Oh, but there's no lights inside, so maybe it's just like absolutely useless. Can I like add a light? Directional light 3D. There we go. And where is it? It's over here. So if I just like put the light over here, do I see something when I hit play? It's so ugly. All right, let's try this. So here I think, yeah, here we go. Can I? We'll add this light like this, and now if I press play, okay, we're starting to see something. And let's just do this. Let's move the camera to. So like what I want to see right now is I want to see that if I procedurally generate a level, I want to see that it's actually generated. So what do I see if I look at this? Let's move it over like this and angle it up. Sure. I don't know. Like something like this. Where's the camera pointing? Preview? It feels like rotated. Am I crazy? Where is my transform? Here we go. 90, 0, 0. Okay, so this is the rotation I want. Sure. That's good enough for now. So now I hit play. I see a map. Cool. And now I want to set up the script to procedurally generate it. So let's start by making sure that I understand how to actually like programmatically generate tiles. So on ready, first let's do grid map clear, right? And if I understand correctly, when I press play, we should see nothing. Good. And now we need to start procedurally generating nodes. So let's try adding one. Add, insert. Oh, fine, I'll actually read the docs. I will actually read the docs. Methods. Set cell item. With a 3-dimensional int vector orientation item. Solid. How do I get the items? Get items. Probably there's something. Item. Do I just have to memorize the numbers? That's so dumb. That is so dumb. Or there's probably like mesh. Yeah. Okay, so what's in here? So we have the mesh library. Here we go. So we can get the item list, returns the list of item IDs in use. Okay, so let's start by saying grid map get item or mesh. What is it? Mesh library? Oh, get meshes? What's this do? Oh, that's not what I want. I want to look at the library. So I think we just have mesh library. And what happens if I like print this? Oh my gosh, you're such. Stop autocomplete. I hate it when things like just don't put what I type. Stop touching what I type, everyone. Okay, so we have a mesh library, and what are the like fields on here are like get item list. That's what we want. Zero, 1, 2, 3, 4. Okay, so then I can probably say for ID in. Do you think that this is how loops in Godot GD script work? I actually have no idea. Get item ID and print this and see what we get. Oh my gosh, I hate it. I hate it so much. Don't touch what I type, please. Okay. So you don't like that. It's not get item. It was something else. Get item name. Okay. All right. There we go. So we need to build up our dictionary of IDs to items. So I'm assuming that we can say like mesh dict is this. I'm assuming, and then probably have to say like var here, it looks like. Sure. We're kind of like doing some like Python JavaScript mixing here. And so I can say mesh dict insert probably add. Cancel save. This is has is blah 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 values. I guess I just probably do this. ID equals this. Yep, and then here we will print the dictionary. Oh, I actually want to go the other way around. I actually want to go from name to ID. Because I know the names, I don't know their indexes. Okay, sweet. Sweet, 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 sweet. So we'll call this get mesh lookup. And this is how we do it. Get mesh ID lookup probably is what we call it. And now we can get this. We say our mesh lookup is get mesh ID lookup. Do I semicolon at the end? Probably doesn't matter. So we clear the grid map. Mesh lookup isn't a constant. What do you mean it isn't a constant? Oh, because I need to return. Shh! Don't make fun of me. I get it. It's not a constant. What is a constant? GD script constants. GD script reference, blah blah blah, var, const, defines a constant. Okay, but what does a constant mean? Literals, comments, constants. Constants are values you cannot change when the game is running. Their value must be known at compile time. I see. So they don't just mean, okay, sure. All right. We'll call it a var then. I understand. And now, let's just... First, we'll just make every single item a dead end to make sure that we can like instantiate things in the grid map correctly. So say for y in 0 to maze size. How do you think do ranges in GT script? It's almost certainly not this. In this? No. For y in range, are they just doing the same thing as Python? Yeah, they are. Okay. X in range, 0, maze, size. We will instantiate a dead end, right? Set cell item. and we'll make the position is y, x, or x, y, 0, I guess. Its orientation is, we'll just make it no orientation. We want the mesh of dead end. Oh my gosh, I'm gonna lose my mind at this. Stop touching what I type. Everyone. Okay. And it looks like it doesn't like this, probably because it needs this to be specific, like explicitly instantiated, and that looks pretty good. So if I hit play now. It's busted. Wow. Mesh lookup. Oh, it's because I called it a function. This should be a dictionary lookup. Okay. Right, because y is up in this world, so we actually want to do x0, z. Start. Okay. That looks like something. I wonder if I can run this script and save its output. Show procedurally generated data in viewport. Let's see. Here we go. Simply add the tool keyword at the start of the script. Okay. Just write tool. Oopsies. Obviously not. That's obviously not what they mean. By making tool scripts. At tool. How do I... Oh, it is literally just at tool. So now if I go... Game? Oh, sick! That's pretty cool! And if I use like a... Oh, that's sick. Okay, works for me. Very nice. Very, very nice. Alright. So now we actually have to implement the maze generation algorithm. So how do we want to do this? I assume Godot has like a vector type. Godot dynamic array. It's probably just an array. Alright. So func generate map, right? And what will this return? This will take... We probably will return a array of elements. Two-dimensional array of it. Turn a 2D maze size by maze size array. And probably we should it should say which walls are open. So indicating which walls are open. And if we really wanted to get like game devy with it, we could encode which walls are open with like a 4-bit integer. But I'm not willing to go there yet. So let's, for now, well, maybe we can abstract that behind a class. Does GDScript have like classes? Class. Is there like learn X in Y? Do you think this has GDScript? So I don't have to read docs? Yes. Class name. my class, sure. Script file is a class itself. You can optionally define a name for it. Oh, that's not what I want. So they just have functions. How do I add like data types? Can I not like add a data type that has data type? Go to GD script. Define data type. Define class GD script. Am I crazy? Oh. I see. So I make like a new script. Ugh, that's a lot of work. That has like exports. Okay. Oh, I wish I didn't have to do that, but for now, maybe we can get away with it. Maybe that makes it actually easier to behave this way. Okay. So we'll figure out the data type as we go. First, let's figure out the algorithm. So first we need an array. So we're doing like we're basically like walking down the stack. We're walking down a path, pushing elements in. So we'll call this just position stack. Right now we are at a position that we should probably randomly initialize. So var start pause is a vector 2i xy, and we probably want to like, I think we want to use a procedural random number generator for this, because that way we can like change the seed in the script and we can see the results in the editor automatically, and then just on ready we can just roll a new seed. That sounds kind of nice. So let's see if there is a PRNG built in. Okay, so we have a random number generator. Pseudo random numbers, nice. And we can set the seed. Okay. So we'll pass in the RNG. We'll create an RNG here. Is random number generator. Oops. Dot type dot new or something. How do I use this? Yeah. And RNG to set seed, I think. Oh my gosh, the key binds. I'm so used to Vim. I want my normal binds, please. Okay, it says they have a set seed, and that works. Okay. Now we call generate map with the RNG. And we'll figure out what this should be later. Start X, we now can generate from the RNG. So we have rand I range from 2, which will be 0 to the maze size. And I guess we don't have to do this. We can just stick them directly in here like this. And is it inclusive or exclusive? Because I need it to be 1 minus maze size if it's exclusive. Inclusive. So here, since I don't want it being 1 past maze size, or I don't want it going out of index. There we go. There we looks a little nicer if I do this. Okay. So now the algorithm says, we also have to keep track of where we visited. And can I is there like a set type in here? Gscript set. It must have one. I'm afraid not. It has arrays and dictionaries. I guess I could just use a dictionary. That's kind of silly. Or... Yeah, whatever. Whatever. So let's initialize the map first. Generate, create, we'll call this generate fully closed map. And this will just for y in maze range. Oh gosh. Oh gosh. No. No. Okay. Range 0, maze size. So for each y axis, we will push this array. We will push for x in range. So we iterate over each element. And oh my gosh, let me move my cursor. I hate being in other editors, man. So we'll call this x array equals this. X array. Oh my gosh, let me out. Okay, so now this is gonna store our objects. So let's just put in, I don't know, man. We'll just put in 0. And we'll figure it out later. This needs to be a variable. Come on, man. There we go. And then after each row, we push that into the returned array. And then we return the array. So I think what I'm probably going to end up doing is I actually will just make this will be 0b1111 is like open walls, and I'll just encode this as like north, south, north, east, southwest or something, and 1s mean that the wall's open, 0 means it's closed. That sucks, but you know, we'll live. Just because I don't really know what else I want to put in here. Oh my gosh. Alright. So var map is this. Generate fully closed map. And we don't need to keep track of visited because we can just check this. If it's fully closed, it means that we have not looked there. Okay. So now we have our position stack. We have map. So now we can say, while the position stack is not empty, so we'll call is empty and put a little like, do you think it's not? Yeah. Position stack dot pop, probably. Does this return something? Where's like my like GD script array reference? GD script array. Let's see it. Let's see it. GD script array. Can I pop? And when I pop, does it give me something? I've popped back and it gives me the value. Okay. So I'll say var position is, oh, this isn't my position. Oh, it is my position. Okay. Position stack pop back. Now I check my neighbors. And I should have 4 neighbors. Unless I'm on the edge, then I will have less neighbors. So I will say func get neighbors for position, and this will be a vector 2i. Oh, I don't have to say that. I can just punch it in like this, and I can say so if my x position is not 0, how do I get my x position out here? Oh, vector 2i. What are my, I have xy. Okay. So if pos x is not equal to 0, my returned value, how do I want to do this? So I have 4 directions, and they're just each based off if I'm in the corners or along the edges. So if pos.x is not equal to 0 and pos.y not equal to 0, then ret gets a new vector 2i of pos x plus 1 and pos y. Oh, this should be minus here. Because I'm going, so if I'm not 0, then I can go towards 0. And I'm going to have several similar if conditions here. So if pos x is 0 and pos y is not equal to maze size minus 1, I can go towards 0 on x and towards maze size on y. And I can do the same thing here if I swap this. It should be maze size minus 1 and pos y is not equal to 0. Oh, here, I'll actually do this one first. This one I can go towards what? Towards maze size on both. And I've done x0, y0. So this needs to be y0, y minus 1. Oh my gosh, I hate this. Okay, here we go. Hello, there we go. And then I return red. Okay, so now I can say my neighbors are get neighbors for position, and we pass in my current position. Now, if I pick, I need to filter these for which ones I haven't looked at. So we'll say check or filter remove, we'll call it remove unseen, remove visited items. Right, so if we now have all of the like possible elements, but we've probably already looked at some. So let's remove those, and we can take in the map and the neighbors. And we will call this remove visited neighbors. We have a new return, it's an array. And for neighbor in neighbors, if we've altered the position, that element in the map, so map neighbor, oh my gosh, neighbor dot y neighbor x is not equal 0, that means that we have set a direction. We are allowed to use that one. We are allowed to look at that. Oops, this should be neighbor here. Okay. So now we can call available neighbors or unseen. Move visited neighbors. Okay. Oh, and we need to pass in the map here too. Okay. Now we pick one over the unseen neighbors, so we now choose one. So chosen neighbor is the RNG a random number between 0 and unseen neighbors dot size -1. That will give us like an index into there. So unseen neighbor. There we go, like this. And now we need to encode. Now that we've chosen this one, we need to flag that as open. So what we have to do here is if there are no unseen neighbors, we pop again. Or we just continue. If unseen neighbors dot size is 0, or sorry, is empty, we should say. Or we continue. We just pop again, which will happen in the first line in the next iteration of the loop. Continue. Okay. And now if we now have a chosen neighbor. It would be nice if these neighbors were, instead of being their positions on the map, were their directions. So let's actually do that. So we can just change these to be like this, right? Like this, like this, like this, like this, like this, like this, right? And then here, this actually doesn't have, yeah, it does. Let me say pause plus this, pause plus this. No, we'll say, var neighbor position is pause plus, pause plus neighbor here. And we'll call this neighbor position. Okay, I think that is it. Okay. Okay, why are you so broken position? Okay. Now we can say, how do we convert our neighbors into dimensions? I guess it would be nice we could use enums instead. That would make this easier. We could have like if we had like enum directions. I don't know how to define these. Like this, maybe. Up, left. How do you make an enum here? My thought is that I could just have a map of this enum to both the vector as well as to the bitmap, the bitmask that I'm gonna be adding here. Right, I could have like a func direction to bitmask, and if I had like up would go to 0b1000, down would go to 0b0100, like etc. And then I could have func direction to vector, and here up would go to like 1 0 or 0 1, I should say. XY, yeah, XY, etc. So let's see how to declare an enum. GD script enums. Let's see. Oh, hurry up. Come on, man. Here we go. Enums. Alright, easy. Directions, up. Oh my gosh, up. And what's the convention here that they use? Direction, up. Do they capitalize everything inside? Yep. And up, left, down, right. Okay. Enter, and we say, is there a switch statement? Match. Match dir. Direction dot up. I assume it's direction dot, but we'll see. Direction up, and here I can just do direction down. Return be 1 0 1 0. Direction right be, oh, this shouldn't be 0 and direction left would be this. And it looks like it's okay with that. And probably for invalid enums, I can return this. And here I can do the same thing here. But this is new vector 2i I actually made a mistake here. I'm putting diagonals in here, and these should never be diagonals, so I have to go back to that. This should be 0 1. And right is 1 0. Left is -1 0. This is 0 -1. And as a safety, let's return a no movement. Okay, so now we can go back to this like generate fully closed map, and we can, this is still 0, and get neighbors for position should now be this like enum. So if y is 0, so now we can, this makes way more sense now. If x is not equal 0, we can go right. Oopsies. Direction right, this. And if pause x is not equal to main size -1, we can add in direction left. And if y is not equal to maze size minus 1, put things down here like this. Boom, boom, boom. Boom, 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 boom. And if we can go up here, and here we go down. Right, and let's just make sure that these line up with these. So up is up in y, up is positive in y, which is correct here, and left is negative in x, which is correct. Okay. So here we just need to call this. And here we can now say remove visited neighbors. Okay. So now that we have a chosen neighbor, neighbor, we can run direction to bit mask. So map at position dot x or y position x should equal direction to bit mask chosen neighbor. There we go. Or equals. So we're adding that as a possible direction. And now we also we can make a neighbor position. We also have to set the neighbor position as the opposite. So now we have to say, we have to have a function to reverse the direction. Function func reverse direction. And we just do the same thing here where we match up, we return down. Down, we return up. Right, we return direction left. And left, we return right. And is there like a raise in here? Raise, throw, GD script exception. Exceptions. Looks like no. Raise. I guess we just don't return here and see what happens. So we find the neighbor position, which is position plus direction to vector shows a neighbor. And we do this again. But we use this guy instead of position. And we invert the direction here. So we say this is reverse direction chosen neighbor like this. Okay, so we've popped our position off the stack. So we need to put it back on. Position stack dot push back position. And now we also want to put in our neighbor position. And I actually think that's might be done. So what happens now if I just print that? Hit play. Null. Fine, I'll return the map. You're so needy. Why can't you just know what I want? Okay, so now we just have all zeros. So clearly we did something wrong. Clearly. Can I like set breakpoints in here? Okay. So we started at 6.5. And how do I step over? Okay, so what's unseen neighbors here? Array of size 0. Neighbors is array of size 4. Okay. So this remove visited neighbors is not working. And that's because we need to, this was an inverted condition. So let's restart. And step over a few times. Oh, I want to help. How do I get out? Continue. Okay, that's looking good. Can I remove my backpack now? Continue. Execution resumed. Where's my, like, output? Output. Null. Restart. Oh, expected 0 arguments. Expected 0 arguments? What the what the random number generator? Oh, it's Randy Range or something. Oops, this should be rand range? Is that what it is? I guess we'll just find out. Hey, there we go. So none of these are 0. That's a really good sign. The whole map is populated. Also a very good sign. And let's see what like 9 is in hex. Or like, can we print as hex? Or binary even? Blender print as binary. Not Blender, what am I talking about? Godot. Nope. I'm not implementing that right now. I know it's doable, but I don't have to. Okay, so now I can now just say I can make a new function now that converts this mapping to a mesh and an orientation. Oh, this is sick. Okay, so we can say open wall mask to mesh and orientation, right? That's a mouthful, but that's okay. So mask is our first argument. Mesh lookup is the second. I think that's it. So we say match mask. And we actually want to like count. So we the number of bits that are set is which mesh we want, and the orientation is like which one is 0. Is there an easy way to count zeros or count ones? I could just like keep shifting and incrementing. I suspect that there's some clever way to do this, but for I in for x, nothing in range 0, 4, we're just gonna do this way. Let temp const var temp equals 4. We will do this 0 while temp is less than 4 plus this equals 1 or something. We don't need semicolons. And mask temp and 1. Here we go. So for shift in range 0 to 4, we say temp plus equals, this isn't temp, this is number of ones. Okay, so we'll shift 1, 2, 0, 1, 2, or 3 times. And each time we see a 1, we add that to the number of ones. And so now we can say match num ones. And if it's 0, it should not be 0 ever. If it's 1, we turn mesh is, we'll start with look dead end. If it's 1, it stays as dead end. If it's 2, we don't know if it's straight through or 90 degrees. Okay, so maybe just counting ones is not reasonable here. Maybe we just match the patterns. Which means we can actually just take the mask in. We just match the mask. And what do we know? We know 0B001. Can I match multiple at once in GDScript? Match. Patterns. Do I comma separate the pattern? First element is start. Okay. Yeah, just comma separated. Oh, but I guess like the orientation, do I just map each of them specifically to position orientation? That's like fine with me. Mesh lookup dead end, and this is beam orientation. So this is the open wall is right, which means that we probably have like 1 for orientation. What doesn't it like here? Expected closing bracket after. There is a closing bracket. I guess maybe I return like an array instead. Maybe they don't have tuples. Yeah, here we go. So here, this is looking down. So I think that's zero spin. Let's assume clockwise rotation, but I don't actually know. We might have to adjust these later. So this is a right-facing wall. Oh, this was left-facing. Right-facing. And this is up-facing. We almost certainly will have to adjust these later, so let's make these variables. Const up rot is 2. Const down rot is 0. Right rot is 3. Const left rot is 1. Is that right? So this should be right rotation. This should be up rotation, down rotation, left rotation. Oh my gosh. Oh my gosh. So this is now, we're gonna do the 2s. This is awful. This is an awful way to do this. I really hope that there is something better than what I'm doing. So these are straight. So where are my, yeah, these are straight. And we'll call this like left rot. And these are symmetric, so I only need 2 of these. No, this is the default position, and this is the left position, and this, we should not call these up, down, left, right. That's stupid. These are obviously degrees, but we'll figure that out later. 90 degree. Oh no, redo. We obviously need another one here for the other rotation. This is wrong. So this, uh, let's assume that the opening in my default mesh is, oh gosh. Okay, where can I like look at the mesh library? 3D. So the dead end, what direction is this? The opening faces positive Z. The opening faces positive Z. So let's assume that positive Z is up, positive X is right. Okay. So say opening faces north by default. Positive Z is north. Faces up. Positive Z is up. Positive X is right, I think. Which means we should have this, we can just say const no rotation is 0 on the orientation. Can I just look at this? Set cell item, set cell item, set cell item. Let me look. Set cell item, set cell item. Rotation is, oh my god, get orthogonal index from bases. 24. Oh no. Okay. Oi, 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 oi. Get orthogonal index from bases. Okay. So we just have to like make these. So let's go back to here. And we just have to like, no rotation is basis 0, 0, 0. Hello? What does it not like now? No constructor of basis matches the basis. Okay. Whew. So I guess I'm assuming that the basis is like a direction. 3x3 matrix is used for 3D rotation and scale. Contains 3 vector fields, which typically interprets the local basis vectors of a transformation. Oh my gosh. This is annoying. But I can construct it out of axis angle, which works for me. Is axis angle the angle is clockwise or counterclockwise? Fuck. Okay, let's assume clockwise. So this is going to be a y-axis rotation of this is just nothing. Not found in base. Get orthogonal index from bases is not found in base self. What does that mean? What does it mean? Get orthogonal axis from basis. Godot. Let's see it. Get orth. Oh my gosh, what do you want from me? Grid map. Orientation. Hello, 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 hello. Oh. Oh, this is just part of the grid map? Gosh. That really sucks. What an annoying API. I understand that it's like maximally flexible and compact, but I hate it. Okay, so if I do this. Okay. Okay. So now we have no wrote 90, and this is like pi over 2. Please tell me you have a pi of constant. Oh, sick. They actually do. I was actually ready to get mad because I didn't think it was going to. And we'll call this rot 180 will be rotated by pi over that axis. Man, if this actually like works first time, I'm gonna lose it. I bet you that there's gonna be some nasty bug hunting going on. Because this is a lot of code and never a lot of code to never have been run. 270, and we'll call this pi 2 times pi over 3, is it? 2 or 3? No, 3 pi over 4. 3/4 pi. Okay, so the dead end, if we have a north wall, is no rote. A east is 90 degrees. This is 180 degrees. And this is 270 degrees. Okay, so the 90-degree bend is by default pointing... It's a right bend with the opening north, so that means that it's pointing west. So up left is the default, which is this. Which means that this must be a... Up and right is a 90-degree rotation. Which means that this must be a 180, because it's the complete opposite, which means that this must be 270. This is no rotation, because the opening faces north by default. This is the way it's not facing north, so I can do rot 180. Okay. So then for the 3 version 1, north, east, and west is going to be the no rotation one. So this will be mesh lookup 3-way no rotation. And now we just have to slide the 0 around. So if I rotate 90 degrees, the only one that will not be open is the west one. I think. This is so complicated to think about, and I'm just kind of doing it on my head, so I apologize. I apologize. But the payoff will be really lame. This is exactly why this project needs to be done at all, right? Because who is going to watch this stream of me just punching in numbers? But if we had the maze running right here, man, would there be something exciting to look at. Something way more exciting than me writing no code at all. Speaking of, I wonder if there's anyone in my stream. Wow, 1 viewer. I bet it's me. This is the dream. We're living the life. Okay. Let's punch in some more numbers. This is like data entry, but even more boring. Okay, so we've done... Let's close the north wall now, and that's a 180 degree. And if we close... So we've done east closed, north closed. No, we've done west, south. Now we need to do east. And this just must be 270 by process of elimination. And And I think I've done them all now. So this is the 4-way, and we need no rotation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Am I missing one? Oh, I'm missing 0, 0, 0, 0, but that doesn't exist. Sick! Cool. So we can say, what is this? Item orientation is equal to open wall mask to mesh and orientation from the map at position ZX. Do I need to do something like this? Expect a variable name after var item orientation like this. Too few arguments? What do you want from me? I need the mesh lookup. Fine. Fine. Okay. This is getting crazy. If this works, I'm gonna like lose it. Item orientation 0. Item orientation 1. What do you think, guys? Let's see it. Invalid index -17 on array. We love that. Absolutely love it. Absolutely love it. So we have position is -13, -16. Also, just absolutely fucked. Okay. Okay, so we go up, down, right, left. Okay. This is just backwards. This is so stupid. I just got all of these the wrong direction. Wait. Wait, does that actually look like something? That looks like something. Okay, let's take a look. Let's take a look. There's no way. Right? Wait. Does it work? No. There is incorrect orientations going on. It does not work. So let's try let's try reversing orientations, because I knew there was like a good chance that it could be counterclockwise and not clockwise. So let's just double check that and see. So where is this? This is 270 and 90. Okay, let's see it again. Oops, that's not the way. There is mismatches between, depending on which side I look, which is not ideal. Not ideal at all. Now, because we've done so much at once, it's kind of impossible to tell where the bug is. So but we could maybe just start staring at these numbers and trying to understand. Calculator. Do I have a calculator? No. So, let's just see if like 999899 is like a thing that makes sense for the top row. For the bottom row, sorry, because that's 0. So 1 is a right? Did we call that? Let's see. Let us see. So Um. Okay. Okay. 9999. So this is y0. We have 9s and 8s. Hello, I'd like to, here we go. 8, 9 in binary. So this has right, this is left, left and up. Because I said up, right, down, left, right? I'm pretty sure that's what I said. Let's take a look-see. What did I say? Direction to bit mask. Up. Oh. What is this? This is just like so broken. This is up, right, down, left. I just didn't change these numbers. Very cool. Okay, does this like at least make more sense? I'm sure there's bugs everywhere in here. But okay, so this is up, right, down, left. And up is positive, down, left, right, left. Okay. Okay, so let's just quickly try switching these again, just for peace of mind. And go back to the 3D scene. I actually don't know if this reloads, which is a problem. Okay, so we know, looking at this, that the borders are fucked. And we also know that it's like fucked in a way that's not just the rotation, because if it were right, we should see all of these having a wall, because they should all, like, if it was just like a 180-degree rotation problem or something. Oh, but it could be like a 90-degree rotation problem. So if I look this way, should I see every single one? Nope. I wish I knew how to like write tests or something. That would be sick, but I don't. So here I should have, I guess I could write like, can I write assertions and just like crash the program? GG script assertions. Come on, DuckDuckGo. Come on, you can do it, buddy. Assert. Yeah, okay. Okay, so this gives me something to work with. I can just start asserting things everywhere and moving on from there. So here, once I generate my map, for z in range 0 maze size, assert map z0 and the up bit, or the down bit, I should say. Assert that these are 0. If I play this, do I hit the assertion? That's good. If I say not equal 0, does that crash? Yeah, okay. Cool. And I can do the same for x. And say for 0, x, left should be. So for each x position at y0, I should not be able to go down. And I should not be able to go up at maze size -1. These should all also be 0. Okay, so that's a good sign. That indicates that like our maze generation logic is doing what we want. Right? So I should see an assertion here. Yeah, because that's a wrong condition. And here I should be making sure that I can't go right at the very end. Okay, so that's a really, really good sign, actually. Really good sign. That means that the map that we generated is almost certainly sane. And it's just the rendering that isn't. And that's, whew, I'll take that any day. So let's just go look at those numbers again. Whee! So let's double check here that all of them, that I have the orientations the way I want. So the straight goes north, south. Oh, we can actually start looking at these in a little more depth. So 12 in binary. 12 binary. I don't want to figure out. So this is north and east. So I can actually look probably at the object at 0z, 0x, and I should see openings north and east. No. Which way have I said is north here? So up I've said is up in Z, which is this way. And I'm assuming this is up in X. Can I like, oops. Yeah, that's positive X, positive Z. Okay, so I do see positive X open and positive Z open. But when I come from this side, the adjacent one's wrong. So that's interesting. So let's take a look at that. Maybe it's in my reverse direction code. Oh, and I can actually check that in standard output. So here, if I run this, where is my print? Okay. So if I have 8 open, 8 binary is only up. So that means that 12. So the fact that this is 2 openings and they're up and right. That's correct because my right was not open. Or my left. So here, what I should see is that this next one over, 13, should have left open, which it will. And then 9 should be, this guy should have 1 pointing back towards 13, so a left, and no right. So that means that this guy should have no left, which he does not. Okay, so it looks like this is right, maybe. So what about up, down? So 10 in binary should have a down on it. Oh, 10 in binary. That does have a down on it. And so 14 should also have a down on it. Okay. So now if I like look at this, I don't know what angle I'm looking at. Um, okay, so can I... How do I, like, know if this is run again? Can I just, like, open this? Why is this RNG not deterministic? That's really pissing me off. Right? Like, if I close this and open this again, I should get the same numbers. Why am I not getting the same numbers? Right? Like, if I play this and play it again, do I see the same thing? No. Like, I should. Why is that? Uh, Godot P RNG random number generator not deterministic. Really? So it's just not. Okay. It's deterministic RNG. Oh, so they actually do still mean random. Hmm. Okay. Well, that's annoying, but it's okay. We'll work with it for now. That is annoying. I was really hopeful. I don't understand why it's not deterministic, but whatever. I guess what we would do. Yeah, I don't really feel like implementing my own PRNG. It's okay. When I open this, if I like close game and open it, I do see new numbers, which means that I should be able to correlate these with actual walls. So it looks like my first item in here has north and east, which I think is right. 12 in binary. Yep, so that's right. And then the problem is that the adjacent wall is rotated wrong. So here, the next item on the x-axis oh, this is because it's mirrored. Am I crazy? So if I'm in here, this is actually correct. It goes north and east. But in no worlds is this north and east. This is north and west. So I actually have to flip my definitions of left and right, probably, to make it... So this should be right. This should be left. Is that what I want? Right, so left, we need left to be positive x. So left is positive x. And does that do anything for me? If I close and open this again. Assertion failed. That's right, because... Okay, at 138, this guy. I swapped right and left, so it should now look like this. Let's open it again. Okay, Get in 3D. Okay. Well, that's something. I don't know, man. I don't know. I do not know. It's also so possible that one of these are wrong. I think that this is going to be easier to handle off stream. So I'm going to take a break, handle this off stream, and come back to it later, because I think that just staring at lists of numbers and fiddling them around is not a good way to spend my time here. So appreciate anybody who tuned in, and I'll catch you on the next one. Okay, found the bug. So now we have a working maze. There's consistency. The edges are working correctly. All of the outside borders are closed, and when you rotate around, there's like consistency in the walls. So overall, I think this is working good. The bugs were a combination of the major one here was that I had 3 pi over 4 for a 270-degree rotation instead of 3 pi over 2, as well as some confusion about clockwise and counterclockwise rotations. So these are counterclockwise rotations, all of these. And I had some confusion about the mappings of directions. So I had right as positive and up as positive, in terms of like positive x and positive z were up and right. And if I look at the maze in the viewport, this is positive x to the left here, and this is positive z up. And so if I have right as positive x and up as positive z, that's actually not possible. That's a mirror of what it's supposed to be, because if this is up, this has to be right. And so the combination of those three were what I had to fix to get this in the right state. In addition, oopsies. There was something else, but now that I've said this, I can't remember. Oh yeah. The other thing that I did here to test was I instantiated each cell manually one by one, using the like open wall mask to mesh and orientation functions, and that really helped me debug this. So I could have done that live if I was a little smarter about how I went about it. Yeah, that's it. Thanks for watching.